Section 13.2 in this chapter 13 is called Principle of Operation. He tells us in this chapter that the operation of a three-phase induction motor initially has to be understood in terms of two principles or laws that we've studied about earlier. Those two principles are Faradays Law and also Lorenz Forces. So let's do a little backtrack here, and just to briefly review what those are. They were, like I said, it may be in 131 or 133. It also is a part of a review in this text in chapter 2, and you may have done that or may not. But let's look at these two things briefly, just to review them. So the first thing Wilde mentions is this Faraday's law of electromagnetic induction. And there's this fundamental relationship that exists between voltage and the magnetic flux in a circuit. And put into words, it says if the flux linking a loop or turn varies as a function of time, okay? If this varies as a function of time, then if the flux changes, in other words, then a voltage is induced in that loop or that conductor. Also, the second part of that says the value of the induced voltage is proportional to how fast the flux is changing. So if the flux is changing rapidly, then the voltage will increase. And put into equation form, and we like math or we wouldn't be in this world, right? Put in equation form, it says that this induced voltage is equal to the number of turns in the coil times the change in flux, how fast, the change in flux over the change in time, okay? So, that amount of flux changing in that amount of time. So if it's changing if a large amount of flux is changing very rapidly, that makes this very large, right? Because they're proportional. All right. Then the other thing in regard to Faraday's law, we can use this equation here that says the voltage induced is equal to the flux density in Tesla times the length of the conductor in the magnetic field times the relative speed of the conductor. How fast is it rotating? If any of those increase, the voltage will go up. If any decrease, the voltage will go down. All right. Then the other thing that he mentions is this Lorenz force. Now, Lorenz forces is based on two magnetic fields, actually. And I'll just go to a little explanation with you. This is supposed to show, this would be a stator here, right? This would be a stator, and this would be a current that is flowing through a coil, and this is turning, right? This is rotating through here. But anyway, that's what that's showing. But what I want to get in terms of the principle is this. And anytime you have current, anytime current is flowing through a wire, there's a magnetic field that's associated with that wire, okay? And, the greater the current, the stronger the field is. So if this current carrying wire is itself subjected to a magnetic field, north and south poles, we think of the flux lines going in this direction, there's actually a force exerted on that current carrying wire based on the interaction of the two magnetic fields, okay? Now, we can quantify that direction with right-hand rules and wrapping fingers a certain way and pointing this and that. That's not important for us at this stage. We just want to recognize that that is a part that is playing in terms of how this induction motor operates, okay? So all of this is going on, and all of these things, and here's this downward force that's being exerted here. So those are the Lorenz forces and the Faraday's law of electromagnetic induction. So let's stop this one and we'll make a second one, and we'll go into this very well-designed explanation of how this three-phase induction motor actually works.